Hello, we are group MTA 16441. If you have ever played on any of these consoles, you probably have heard the sound of chiptune. Nowadays you'll find newer games or songs utilizing the great sound of square, triangle, sawtooth and pulse waves, trying to express nostalgia in current times. Therefore, for this project we will explore how to create a chiptune synthesizer and producing such sound through an output. And secondly, how to make such a system user-friendly and intuitive. We decided to make an initial problem formulation, which is: how can a chiptune synthesizer be introduced to musicians or music enthusiasts new to chiptunes, in a way that usability is enhanced compared to other synthesizer software or synthesizer emulators? With this initial problem formulation, we went to 2 different sites to conduct a user study to gather information about what the user thinks and experiences when it comes to creating electronic music. Therefore, we went to the library and to Aalborg University. From the information that we gathered from our user study, we could formulate a final problem formulation. How to make a synthesizer in order to introduce people interested in music to creating chiptune music in an intuitive way. We went through several design iterations to come up with one final design that we would like to work with. These iterations are the Running Man and Sinusoid Says. And this is the final design idea that we decided on. The final design idea represents a solar system containing a sun in the center. Around the sun you can spawn planets and meteors that will orbit around it and play as they hit the top of the screen. To control the solar system and create and synthesize the music, we designed a physical interface. This physical interface will let you select a waveform, pick a chord, spawn notes, create a beat, navigate through the solar system, and finally undo your recent action. We used 3 different programs for our system: Arduino, which sends a message to Unity, Unity, which produces the visuals and sends a message to processing, and finally processing, which produces the sound. So how did we test it? We did a comparative test where one group tested our product and a second group tested another concept similar to ours named Sequence. The test was conducted at Aalborg University. From the test we found that people who used our program would get to know musical theory better compared to Sequence. This was found through a questionnaire related to music knowledge. We managed to partly answer our problem formulation. It would require us to conduct further testing and in-depth use of music theory to fully cover all aspects of the problem formulation. Now, are you more encouraged to learn electronic chip music?